Greetings, RC Bro here. Today's video is part 2 of our series on RC car batteries. In part 1 we talked about the characteristics and the terms of the battery, we talked about the voltage, and we talked about the S rating. In this video we're going to discuss milliampere hours, we're going to talk about the C rating, and we're also going to talk about charging your batteries. Before we get into our subject, I just want to remind you that the goal of the RC Bro channel is to introduce youth to electronic, automotive, and mechanical engineering through the use and enjoyment of RC cars. That being said, let's get into it. So you get a new car, you come to the battery. It has all the terms that we talked about in part 1, and it has something called MAH. That stands for milliampere hours. Milliampere hours. Well, what is that? Well, basically, the milliampere hours is the capacity of your battery. It's how long it could continuously supply current to the motor and the ESC. So why is the milliampere rating important? It's important because it sets the length of how long your car can run. And that's important because if your car runs too long, longer than it's designed to run, it can overheat, and that can cause permanent damage to your motor and ESC. So if you're replacing your battery and you have a battery that says, that you have 1,000 milliampere hours, then keep in mind if you get one that has 2,000 milliampere hours, that you're increasing the runtime of your car possibly by a factor of 2, but you could be causing damage to your car. So you have to monitor the car. You have to check its temperature. Or you can keep the battery can actually keep the charge longer. However, you may have to stop the car to let it cool before you run it again. Next, we're going to talk about the C rating. The C rating is the characteristic that may be the most confusing. It's not the most important, but it can make the difference in terms of the performance of your car. So I have a battery here that's 2,000 milliamperes, but it has 15 C. I have another battery that's 18 milliamperes, and it's 30 C. I have another battery that has less milliamperes than both of the previous batteries, but it has the highest C rating. It's 60 C. So what does the C rating mean? The C rating is the maximum discharge rate of the battery. It's how much current can be put out or drawn by the motor in bursts, and also consistently or consecutively to supply the motor for the current it needs. So in general, but not always, the higher the C rating, the more possibility your car has to go faster. But in actual usage, you may not notice a difference. You may not notice a difference between one is 60 C and another one is 30 C. But you'll probably notice the difference between a battery that's, say, 15 C and maybe 30 C. So in general, you can think of the C rating as how fast the battery can deliver the current to the motor without damaging itself or the cells within itself. So when purchasing a new battery, generally you want to get the higher C rating, but keep in mind that that C rating may not be as advertised, and you can't expect a higher C rating to automatically make your car faster. And you want to avoid going below the C rating of the battery that came with your vehicle. Okay, so let's go over a few examples. The first one we have here is a battery that's 850 milliamp hours, and it's a 2S. All of them are 2S here except for one. And it's called a polymer ion. which is, I think, the old designation for lipo or lithium polymer. And so you can tell because it's square. So it's definitely a lipo battery. And it doesn't have a C rating on it. So some batteries are like that. They don't have a C rating, and so you can assume it's not very high. But it came shipped with a small car, and it works well for that vehicle. This one's the same size as the previous one, but it's 1,000 milliamperes, and it says on it 25C. So this one has a longer drive time and higher capacity, and more than likely a higher charge. Here we have one that's 13 milliamp hours, and it's a Li-ion, and you can tell because it has the cells in it, the cylinder-shaped cells. And this one does not have a C rating on it as well. So when they don't have C ratings, you can't expect it to be very high. Now this one is 1,500 milliamp hours, and it has a C rating. It's 60C. So this one is rated very high, or compared to the other ones. And it's a lipo battery, and you can tell it's a 2S because you can actually see the two cells in it. Alright, so this one is an 1,800 milliamp hour battery. It's a 30C, and it's definitely a lipo. It says lipolymer, and you can tell by the shape, it's square shaped, and it's a 30C battery. This one is 2,000 milliamp hours. However, it's only 15C. Interesting, isn't it? This one has half the milliamp hours, but it has almost twice the C rating. This one is a lipo. This one is a lithium ion. Here, this one is 3,000 milliamp hours, and it is only 25C. So this has 3 times the capacity of this one. And you can look at the size and tell. And but this one has a higher C rating. Well, they have the same C rating, 25C. Interesting. And last but not least, this is a 3S battery. And you see it, you know that because it says 3S on it somewhere. There it is, 3S. And it's 11.1 volts. And it's 1,500 milliamp hours, so it's not more milliamp hours than this one. But look at the C rating, 120C. So that's pretty high. So now we're going to talk about charging your batteries. To get a comprehensive understanding of the process of what goes on inside your battery when you're charging it, we have to go back and revisit the cells. If you remember in part 1, when we talked about the batteries, we said that your RC battery is actually a battery pack comprised of 2 or more cells. Just like this lipo battery right here actually has 2 cells in it. You can see the cells. And this lithium ion battery, same thing with this, you can see the cells. It has 2 cells. And each cell, remember, has a nominal voltage of 3.7 volts. Nominal means that's the average or the target voltage that manufacturers are aiming at when they make the batteries. In reality, the batteries are slightly higher or slightly lower than 3.7 volts. Might be 3.71, 3.72, or 3.69, 3.68, but the at-rest shipping value is approximately 3.7 volts. The maximum that each cell can be charged to is 4.2 volts. The minimum voltage that should be maintained on it for the livelihood of the battery and for safety purposes is 3.0 volts, some say 3.1. So your 3.7 volt battery has a range, a lower range of 3.1 volts and an upper range of 4.2 volts. So when you're charging it, you charge it up to 4.2 volts, and when you run it, you discharge it down to 3.1 or 3.0 volts. Your chargers that you have that comes with chargers similar to these that come with your RC cars, they are programmed to detect the voltage and to charge it to a maximum of 4.2 volts per cell. Your ESCs in your cars, are programmed to run your car down to where it's only 3.1 volts per cell. They're programmed not to go any lower than that. However, some of these are programmable, and you actually can change that. But you really have to know what you're doing, because you can destroy a battery by letting it go down lower than 3.0 volts. So now let's talk about the battery range. The battery comprised of two cells, the whole battery voltage range. The nominal voltage that we said for each cell was 3.7 volts. Therefore, 3.7 plus 3.7 is 7.4. That's how we get to 7.4 volts on these. If we charge each cell to 4.2 volts, that gives us 8.4 volts. So that means the maximum voltage that these can have when they're fully charged is 8.4 volts. Once again, the cells, when they run down, their cutoff or minimum voltage is 3 volts. That means that your battery pack minimum is 6 volts. So the range for a 2S battery is 6 volts to 8.4 volts. You don't go over 8.4 volts, and you don't go below 6.0 volts. That being said, we say that this battery is comprised of two cells. What if the cells are slightly different? In reality, they almost always are. The cells have different characteristics on maybe a tenth or a hundredth of a volt. So when you're charging it, how does the charger know which cell reaches the maximum or minimum before the next? If the battery charger doesn't know that, then it can easily overcharge one battery and undercharge another, which will be detrimental to the life of your battery. That brings us to the concept of load balancing or cell balancing. And remember, we talked about this other connector here. We said that there's two connectors in the battery. There's two pairs of wires. One wire is the connector that goes to the ESC that powers the ESC and the motor. And we said this is the other pair of wires is called your balance lead or your balance tap or your balance connector. Well, your balance lead is how your charger knows what's the voltage on each cell. If you notice in the diagram, you can see how it's connected, how the balance lead can actually be used by the charger or a voltage tester to actually tell what the voltage is on each cell. A 2S battery pack has 3 wires. A 3S battery pack has 4 wires, and so on, so that your battery charger or your voltage tester can actually tell the voltage on each cell, and within its programming determine which cell needs to be charged and which cell needs to be stalled or not charged. And that's called balanced charging. And that's very important for the life of your battery and the performance of your car. There's 3 types of ways that you can charge your RC battery. There's regular charging, there's balanced charging, and there's storage charging. Regular charging just measures the voltage across your 2 batteries if it's a 2S or your 3 batteries if it's a 3S. And it measures the total, and when your battery gets up to, if you're charging it to the full capacity, when your battery gets up to 8.4 volts, it stops. So you don't know which the battery voltage is in the cells. One cell could be overcharged and another one undercharged, giving a total of 8.4 volts. And that's not good for the life of the battery. So now that brings us to the next type of charging called balance charging. Balance charging actually uses the balance tap to measure the voltage on your two cells, if it's a 2S, or 3 cells, if it's a 3S, and so on. It actually measures the voltage in each one, and it measures them each individually, so if you're charging it to run, that they are all the same at the same voltage, whether it's it's going to be 3.7 volts, or if you're charging it 4.2 volts per cell. So when all the cells are at 4.2 or as close to 4.2 as possible, the balance charger stops the charge. Another way to charge is called a storage charge. The storage charge is used to store your batteries. Lipo and lithium batteries don't store at full charge, and they don't store well at full charge, and they don't store well at the minimum charge. So you're never supposed to store a lipo battery with 3.0 volts per cell, which is the minimum, and you shouldn't store it at 4.2 volts per cell, which is the maximum. The ideal voltage to store is called the storage voltage, and that's generally around 3.65 to 3.8 volts around the nominal value of the battery of the cell, which is 3.7. The way to achieve the storage voltage is with a charger that has that option to store it, or you can do it manually, but it's pretty cumbersome by charging a little bit and measuring the voltage at the same time, which is a little complicated. And so generally what you do is you purchase a charger that has the capability to put a storage charge on it. And we're going to talk about chargers in part 3 of the video. Meanwhile, we're going to take a look at some of the chargers that you get with your RC cars. I have in front of me some typical RC car battery chargers. These have come with the cars that I have. This one came with WL Toys, and this one came with, I think, my Hosim and my JBX and my HBX cars. And this one, I'm not sure what it came with. It may have come with the DRC. I can't say that they are balanced chargers. They are probably not. I don't know, because in the manuals they don't talk about balanced charge and storage charge. So I don't know how they work. I don't know if they just charge or they do balance, but they definitely don't do storage charge. That's for sure. So they don't leave the manuals, as I showed in part 1. The manuals don't talk about storage charging. They just tell you not to charge it fully, not to store it fully charged, and not to store it fully depleted. So one of the first things you're going to want to do is get a decent charger if you're going to get into the hobby and have more than one car, or if just one, to get a decent charger. And we're going to talk about that chargers in my next video. But these are the typical chargers, which I've collected a lot of them, but I don't use any of them because they don't store, and I don't think they do balance charging.